大家好，我们现在在华大，现在是在我看哈，这个是什么房间？叫维雷芒 room。OK， 我们今天参加一个台湾的 AI 的一个讲座，现在有很多就是朋友来参加这个活动，现在正在登记。我们看看哈，待会儿进去看一下，里面应该有很多朋友已经在里面。开始吧。我们
刚好看到他的。
哦，你们看
OK，
刚好。
那我们进去看一下，已经开始了。
因为邀请来自很多台湾跟西雅图当地的科技圈非常优秀的专业人士哦，包括学界啊、产界啊，以及各种的专家学者、创业家，还有科技领袖，都要来带我们一起探讨和探索 AI 的产业趋势。本次论坛的初衷呢，是希望透过交流、职涯分享以及跨境的合作，来支持我们这些西雅图的台湾人才的培育，然后也进一步的强化科技产业以及学术界呢之间的连结与对话，主要是以嘉宾分享还有轻松的晚餐的方式，让来自各界的朋友互相认识交流。然后要特别强调哦，这次活动非常的特别，因为是第一次西雅图呢在地台湾科技社群首度自主发起的一个盛会，我们对此感到无比的骄傲跟荣幸。在此呢，我们要特别感谢以下单位的大力支持，让这样的聚会得以呈现。首先是驻西雅图台北经济文化办事处，然后是西雅图华侨文教服务中心，再来是旧金山台北经济文化办事处的科技组，最后是北美洲台湾工程师协会的总会。谢谢你们，才有我们今天的这场活动。So we're thrilled to have so many talented professionals across different industries today with us. And this is the very first event of its kind, driven from the ground up, local Seattle community. And we are truly grateful for the generous support from the organization of different Taiwanese local organizations. 好，现在来正式开始我们的活动。首先呢，我们邀请 Dr. Shih-Chieh, Director of A3D3, Professor of Physics and Adjunct Professor of Electric and Computer Engineering 在 UW to deliver our official opening speech.
Seattle has rapidly emerged as an innovative city for the AI. With nearly a quarter of America's AI engineers and are here in Seattle, and we have built a vibrant AI ecosystem, and also the startup and research institutions calling this city home. Meanwhile, Taiwan stands at the heart of the global AI innovation. In particular, producing more than half of the world's AI chips and fueling innovation across industries with the world-leading semiconductor industry. As we gather today, let's ask these questions. What groundbreaking opportunities and challenges could deeper partnership between the United States and Taiwan unlock the future of AI? Hello everyone, my name is Shih-Chieh. I'm a physics professor and also a joint professor in Shih-Chieh at University of Washington. With Taiwan, I'm also a adjunct faculty in the National Tsinghua University in physics. I currently am the director of the NSF HDR Institute called ACD3. In ACD3, we focus on enable real-time AI techniques to accelerate science and engineering discovery. HAT3 is just one of the nationwide institute initiative in University of Washington. In Washington, if you talk about AI, we are ranking number 7 as the best AI graduate degree program in the United States. And if you talk about best university AI in the world, we are number 10. What does that mean? It means if you talk about leading AI institutes in academic, United States really dominant in the very far, very proud that everyone here we are achieving right now. And University of Washington, in the world ranking, we are ranking number 25. This number is more than just a number. It really shows in Seattle, in this city, we have the talent and in the world level gathered around in this area. We are pushing different frontiers of the AI in different type of the domain knowledge, and particular in the University of Washington, we are focusing on interdisciplinary collaborations. We also built a very strong partnership with the industry. In UW, we have a startup hall, and we have a promotion, try to promote the academic ideas into the industry sector. This is closely synergy to the industry level in the city. We have a newly established AI house. This is really wonderful, and we also have many platforms. For example, the Cross-Pacific AI Initiative and UW Amazon Science Hub. This shows how UW has established strong binding between the academic industry. So now is the time we can think about, many of us here, we have a special connection with Taiwan in different ways. How could we, using our advantage, to build Taiwan AI Hub here with a strong academic industry binding? Let's start right today. Thank you.
Thank you, Dr. Xu, for setting the stage for us today. Next one, let us welcome the Dr. Ahmad Izzadin, Vice President of Global Affairs at the UW.
Good afternoon. Good afternoon. Welcome to the University of Washington, and we're so excited to have you here. As Dr. Su mentioned, he did mention that we are one of the, University of Washington is one of the leading and most innovative universities in the world, global universities in the world. Number 7, I think we are number 7. So it's only fitting to be talking about innovation, research, and cooperation, and new talent, and how do you support new talent and AI right here on campus. So welcome. We're so glad to have you host this conference here, this forum here on campus. You saw you're coming in, probably you saw we have 2 groups of students today on campus. We have students who are graduating, and we have students who are taking their finals today. But it's really, we are very proud to be an institution that really produces talent that is ready for all of the innovative needs of the world. And AI is really at the top of that list these days, right? And I am new to Seattle. I arrived to Seattle 4 years ago. 4 months ago, not 4 years ago. 4 months ago. It sounds like it feels like 4 years. 4 months ago, and previously at my previous institution, we worked very closely with Taiwan. But I was very pleased to know that the strong ties that the University of Washington and the Seattle community have in Taiwan. We have more than 500 Taiwanese students on campus. Taiwan ranks among the alumni that we have, international alumni. Taiwan alumni from Taiwan are on number 5, basically on the list. We have 6.5% of our international alumni are from Taiwan. And of course, we have all of the amazing, great faculty who are doing research and teaching and collaborating with their counterparts in Taiwan, which we hope and we are committed as the Office of Global Affairs to really support and continue to support and invest in those collaborations. I wish you a very productive conference this afternoon and look forward to hearing about all of the outcomes that will be result from the discussions. Thank you.
Continue support for Taiwan. Next one, we are pleased to welcome Dr. Yao Hong Yang. Okay, let's continue to welcome Dr. Yan for encouragement. Dr. Yan is the Director of Science and Technology at TechCo, San Francisco.
Thank you. My name is Hongwei Yan. I'm the Director of Science and Technology Division. I was posted by National Science and Technology Council, Taiwan, in Silicon Valley. Actually, I was here in last September 2024. Before then, I was a professor in Donghai Daxue. My background is chemical engineering. So I'm going to spend about 10 minutes to introduce a little bit about our job. That's why NTC will post me here in Silicon Valley. Please allow me to use Mandarin, maybe more easy to people to understand it. 国科会我想跟大家介绍一下国科会因为大部分人其实不是很清楚国科会National Science and Technology Council。国科会在美国，它总共有5个组包括在旧金山、LA、在 Houston 跟 Boston 还有 DC。那我们的工作our job is trying to strengthen the cooperation between Taiwan and the United States。在这个基本上在国会里面有一个非常重要的事情，跟大家会比较有关系的，就是所谓的千里马计划那we so-called the postgraduate students and also the postdoc students study abroad。那千里马计划里面在博士班学生，那会有国科会出资提供经费那千里马的博士生跟博士后。基本上就是，如果您跟台湾的老师有认识尤其是 faculty 跟台湾老师有认识，那从台湾的老师那边，他可以选送他的博士生或博士后来您的实验室，那他的经费呢是由国科会出。那你可以看得到这个所谓的 PhD student 跟 postdoc 那博士生呢，他基本上是来待7到12个月。那博士后呢，最多待2年。那他在经费上呢，博士生呢大概是台币90万，所以你可以算到1年大概就是3万美金。那博士后呢，大概是5万美金。那这个是对我来讲，它的意义就在于说，你可以跟台湾开始有一些 connection，那建立你跟台湾的合作关系。这个部分呢是在 academic 上面。那个黄正老师呢，他对这个系统就比较清楚，他有很多的千里马的博士生曾经来到这边学习所以如果有任何问题，您可以找我，或者可以找黄老师请教那在今年比较特别的另外一个是 content 我会以为以前在所谓的千里马的所谓的 graduate student 这一块它并没有特别规定任何一个领域，但是在今年特别指定出一个 content。所以换句话讲，像我不知道徐老师的研究里面有没有 content那如果说有 content， 这代表说国科会特别指定某一部分的 budget， 让 content 相关的博士生或博士后来美国学习所以这会是一个蛮好的一个机会那我们来看一下一些数据这个数据是博士生跟博士后在过去5年来比方讲2025年，它总共有305件申请，231件通过，所以它的 passing rate 有大概是70%，所以其实相当的高所以这个在这个申请件上，你可以拿70%的申请案件都可以通过所以是一个蛮高的。那您可以看到从上面来看，你可以发现说 application 的件数也是逐年的增加 这个就是刚刚的那个数字哦，所以你可以看到它的通过率哦，从最早是60几%，一直逐渐拉到70几%哦，所以这个就是说国科会在这个部分投资了相当多的 budget 啊，所以欢迎所有在 UW 的老师啊，或是在其他的老师可以使用这个部分。那这个就是对于所谓的 academic research 啊，那个国科会鼓励台湾的老师送他的学生来这边啊，那这比较侧重在 academic 上的 study。但是呢，对工业界对 industrial 来讲呢，我们有另外一个计划叫 excellent。excellent 的那个概念是这样，它是来做什么呢？做 intern 啊，所以如果业界啊，说各位不管是在哪一家公司，那它的原始的想法是这样子啊，就是说如果这边的公司它有意愿回台湾去开分公司，那一开始的时候你可能不认识台湾的任何人，对不对？那你在hire anybody的时候，你会有点 risk。所以最简单的方法是什么？就是国家帮你，台湾帮你出钱，我们找一个人来你们这边做 intern， 最多1年。那这1年结束之后，你说觉得这个人还不错，你就把他送回台湾去开你的分公司，他就变成你的干部。好，所以这是 for industrial 来讲，他可以做 intern 来这个地方做1年的一个时间。那他的经费那个经费上是由国科会出5万，就是1年最多就是5万美金，那待1年。好，那当然以5万美金来，它是150万台币，对，要5万美金。以5万美金在 Silicon Valley， 我常被 challenge 的问题就是那个钱不太够啊。那当然，对 Silicon Valley 来讲，你5万美金大概连租房子都有问题的，但是至少它是一个补贴啊，当然是一个那个或多或少一个补贴的一个作用。所以再回过来讲一次在 academic 上面，我们有所谓千里马计划鼓励那个老师在研究上面跟台湾合作。在 industry 上面，我们有所谓的 excellent 计划啊。那 excellent 上面这2个经费，主要大部分当然都是就由国科会来指引啊。那这是那个它的一些规范那我想这个有一些细节，但是如果说大家有兴趣的时候，再告诉我。好，那它的那个 excellent 的计划基本上是这样，就是说您的公司要先跟国科会申请那国科会当然要审查一下您的公司的一些 background 资料。那如果 OK 了，我们就把你放在我们的 excellent 的那个 data list 上面，然后开放给台湾的学生，台湾的不是学生，台湾已经毕业的年轻人来申请国科会帮你做一些初步的筛选他会做一些 selection。那把 the final decision is made by your company 你们自己做最后的决定。那它通过了，就会送过来你的这个地方，你的公司开始实习1年这是一个 process。那这个 process 现在已经在 ongoing 的状态所以如果说您有兴趣的话，就是再想一想，然后在年底的时候可以来提出申请。好，那最后一件事情，我其实也要非常感谢徐老师李荣华老师就是说大家知道说 Silicon Valley 是一个跟台湾有非常强的 connection 在过去以来，但是我们一直认为说，除了 Silicon Valley 以外，其实 Seattle is getting more important and important, and we need to create something in Seattle。所以在去年我刚接任的时候，其实有跟汪老师、有跟徐老师提过一件事情，说我们怎么样可以创造一个平台让这边的台湾的工程师、台湾的老师，大家可以聚集在一起，就像今天这样一个 gather 一个活动。那在 Silicon Valley， 我们在耀宏在马蒂亚这个部分他今天没有来。在 Silicon Valley， 我们国科会每1年都会 support 2个那个所谓的年度 annual seminar supported by NSTC。那是就是一个非常好的一个 platform 那在那个每1年大家都会聚集起来见个面认识，然后互相聊聊天等所以我非常期待说，在 Seattle 我们也可以有这样的一个活动，让它行之有年那今天是第1次开始，那我们希望往后也有更多的也有可以这样 continue 的下去那我举个例子来讲在它的那个所谓的 NATIA 那个就是北美工程师学会，它在矽谷的分会它每1年就会办一个所谓的 annual conference。那大家可以看到，过去几年，从19年开始，它其实更早，它已经到现在已经超过大概10年左右从19年的那个 topic 这个放在上面 那这些 topic 呢，就是等于是在当年度它是一个非常 hot 的一个题目哦，那就是让大家起来一边是交换意见，一边互相学习。那更重要的是，它是一个 social activities， 让更多的，不管你已经在 Silicon Valley 多久哦，老的、新的，然后它可以创造一个平台，然后大家相互认识哈。所以大家可以看到，它每一年的办活动都像这样子哦，都有上百位那个在 Silicon Valley 的 engineers 哦，他或是一些老师大家共同的参与哦，那它会形成一个传统，让新到的或是很早以前就来了，那大家可以互相的帮忙哦。那我觉得这是一个蛮好的一个方式哦，那也期待说在 Seattle 也可以创造这样一个活动，那国会会来积极的协助大家。那以上我非常简单的一个报告，谢谢大家。
Before we move on to our presentation and keynotes today, we would like to take a moment to honor a few of the outstanding representatives from our organizations. Without them, we do not have the events today. First of all, 华盛顿大学台湾教职员工协会代表徐世杰，谢谢。西北区成大校友会会长 KC， 西雅图清大校友会会长葛宇志，在后面。西雅图阳明交大校友会会长 Joey， 谢谢大家。太平洋西北台湾人生物医药协会蔡宗义，最后一个是西雅图台湾商会会长 Hans Wang。感谢各位了。然后呢，除了这些人之外，我们也要感谢今天的特别来宾，就是他们的 support 呢，让今天的活动可以达成。首先是美国西北区台大校友会的会长吴小燕。
这个机会啊，欢迎大家。如果你要做一个商会的，要做一个大会的会长啊，有一个很重要的关键，就是要找许世杰这种副会长，你就没事干，就很容易就可以把事情都办好了。我们很高兴大家的参与哈，今天参加这个 topic 是非常有趣的，因为可以影响我们今后的生活。如果在大家我自己完全对这个 topic 是很陌生，但是呢，这个 topic 对我们今后我们人生、我们个人的生活都有很大的影响，所以很高兴大家今天的参与活动，也谢谢我们副会长许世杰的努力啊，有一个很愉快的下午，谢谢大家。
然后也感谢我们的侨委会的委员温在兴委员。好 ，Now let's start. Let's begin our seminar talks. And our first speaker is Professor Zheng Ling Huang from UW Electrical and Computer Engineering.
Okay, I'm Zheng Huang from EC Department of UW. I was given only 15 minutes, so I'm going to speak very fast, so please buckle up, okay? Because Shih-Chieh asked me to talk about these important topics in AI, so I got to cover a lot of these new advancements in AI technology. Okay, so the reason AI getting is so important is because we have too much data. We call it big real-world data. So because of those big real-world data, we need to analyze it because everything is already stored into computers. So we need to analyze them. So that's how machine learning is invented. Machine learning first, from so much data, I need to get some kind of important embedding features. We call it representation. After that, then we can design the machine learning algorithm. No matter you use something called supervised, unsupervised, or reinforcement learning. The idea is how you use those data and are those data being annotated with labels or not. So those are called machine learning algorithm development. Finally, we can talk about application. So if you think about that, you can divide all these machine learning algorithms into the encoder and the decoder side. And the encoder is trying to get the best embedding feature. Decoder is trying to see what kind of machine learning algorithm, as well as what kind of application you want to accomplish. If you think about human brain also roughly divided into two different types of intelligence. Number one, we have the perceptual intelligence, which in response to the outside stimulus, we respond to the visual side, audio side, and everything. Those are called perceptual intelligence. At the same time, we also have the capability of performing generative intelligence. So the whole idea is we can do reasoning, we can do imagination, we can create the content without the external excitement, without the external stimulus. We can still create something. So these two intelligence, how are they being finally become artificial intelligence? So in order to talk about artificial intelligence, we need to understand our human brain. Our human brain consists of 10 to the power of 11 neurons. Each neuron roughly talking with roughly the neighboring about 1,000 neurons. And the way they are talking with each other is kind of mysterious. So for engineering perspective, we simplify it into a very simple equation. All other neurons information is multiplied with something called synapses. And that some of the product of those multiplication become something the neurons potential. And those membrane potential will be propagated to the other neurons. So that is a very simplified model to describe our human brain neurons activity. And what is the important part is that nonlinearity. After you receive other neurons information, how do you become a new neurons activity to notify the other neurons? They through something called nonlinear activation. And that nonlinear activation function can be something like a sigmoid shape or the rectified linear shape. So now I quickly described one single neuron's activity. How about 10 to the power 11 neurons? How are they connected? And in the early days, people believe maybe the simplest way of connecting all these neurons is through something called multi-layer perceptron, which the input becomes some kind of data, and the neurons are laid out as layer by layer. Okay, and every neuron's operation is just like what I talked about, sum of product concept. Then eventually, all these neurons passing through so many layers of neurons activity, finally they will produce the output. And that output can be, for example, face recognition. Oh, this is my friend A, my friend B. So that's called classification. If we want to predict, okay, tomorrow's stock value is what? That's called regression. So how do you learn those neurons activity? We are learning those connections. Those are called synaptic connection. And that algorithm was invented in 1985 called backpropagation, which allowed the very complicated large-scale neurons in order to learn each other through learning those wave parameters called synaptic. But then quickly people realize the neurons, those connections are not necessarily need to be fully connected. So people start to talk about can that be partial connection. So we are talking about now the neurons are partially connected. And can we also share the weights, which are those connection weights are having the same value, and that was called convolution neural network. Okay, and what if the input is two-dimensional data, like image, like our visual input, or can be even audio input? So all these data, you look at this, looks like they are one-dimensional input data. In fact, it can be a two-dimensional image, it can be three-dimensional input data. So it's just laid out the purpose. So in terms of connection, which are very similar. The most important part need to emphasize is about those connection which are something we are going to learn. Those connections compared with the data in the previous layer, we perform this something called pattern matching. And that pattern matching gives you some degree of what kind of similarity between that kernel, that convolution kernel with the value in the layers. And that gives you the next layer's intensity. So you bear this in mind, convolution neural network is performing some kind of local window search and try to know, is there any area, is there any data which are similar to the kernel I learned? And again, no matter what kind of connection, the backpropagation can still be used. And now we are talking about perceptual type of AI. Perceptual type of AI roughly can be categorized into classification, given one image or given one audio sound. Can you tell me what's that? That's called classification. If you also want to know the location of that object inside the image, we call it classification plus localization. If you have multiple objects you want to know their location and what are they, it's called detection. Finally, you can also segment the object. That's called segmentation. So, why people suddenly find out that this neural network architecture is so important? That's because in 2012, there is a big database called the ImageNet database, which consists of 1.3 million images, and in total 1,000 different categories. And they want to ask people to identify each image that belongs to which object out of 1,000 different classes. And the neural network architecture called LSNet turns out to be the number one, which outperform with a much higher magnitude compared to the number two winner from University of Tokyo. So that's how at that time people open their eyes and say, neural network architecture is quite useful. And people after 2012 become increasing the number of layers. After 2015, we increased to 150 layers of neurons. And that's become even much better than human performance. So if you look at how these architecture are being interpreted as our traditional machine learning concept, you can still think of convolution layers. These are convolution layers which are also performing some kind of important embedding feature extraction. After that, the multi-layer perception layer in the last three layers is performing some kind of machine learning algorithm, which is classification or regression. So why this type of architecture is better than the traditional machine learning algorithm, which we have studied for more than 30 or 40 years? Because the main reason is because they are single stage end-to-end. We treat those machine learning parameters and those final layers of classifier, they are together being learned, being trained. So they can be trained simultaneously. This is the first time we realize embedding feature and also classifier or the machine learning model design can be jointly trained. And because of that, we find out it is a much better alternative than conventional machine learning algorithm. So you can still treat this as this side is encoded, that side is decoded. So how useful are they? For example, this is 2018, we joined the AICD challenge of the world. Out of 40 different teams internationally, we got the number one, which try to track the same car over 40 different cameras. And we can continuously track that car. And in fact, not one single car, all the cars. As long as you are within that 40 camera, we can successfully track you. Okay. Then we can also use this detector to make your car become a three-dimensional car. And for those of you driving Tesla, you really every day you are seeing all your labeling cars like a 3D bounding box. Same thing, we just use one camera because Tesla uses 8 camera. We just need to use one camera. We are able to make that car become three-dimensional car. Similarly, if you are in the raining day, in the very dark environment, can you still do it? Yes, you can use a millimeter wave radar to also do the same thing, or to also detect and track all the vehicles. We have been working with American law, try to also make those fishing boat activity become AI enabled. For example, they use this electronic monitoring to monitor all the fishermen captured. At real time, they can convert it into the digital information, including what kind of fish, how big is that fish, and other important parameters. Not only through this kind of, they send the fish into something called a chute. They can also real time put the camera next to the fishing boat. They can real time capture all the catching activity. Similarly, we talk about also segmentation. Segmentation as well as tracking is so important for a lot of daily life application. For example, this is one of our techniques called Semira, which allow you to track and segment the object real time. Even it's only a single object. For example, you are tracking the player inside the game, including segment their body, or you can do the multiple object segmentation and tracking. Furthermore, some of you may be curious, if I can track and segment the human body, can I also know what they are doing? So we talk about this called human pose estimation, which we track the human body in terms of laser joint, converted from 2-dimensional key point joint to 3-dimensional key point joint. And we use this to detect the early symptom of autism of the baby before 9 months old, who cannot speak, who cannot communicate, but we already know is there any symptom of the autism because of their moving capability. Okay, and we also help a Singapore startup company called KOCAM use this or put it in your house. Every day you just need to perform sitting on a chair, walking about 10 meters, come back. They can give you a healthy report. Okay, it's called TUG, time up and go test. So that's also very important. You don't want to go to hospital every day to do this, and they can do this at home. We also have a local company called Sports Bus, which asks us to help them to come up with a 3-dimensional human motion modeling. So, which now this system has been used by more than 10,000 coaches in the world, teaching the kids, teaching the people how to play golf using the 3-dimensional model. Okay, so that's so much about perceptual AI. At the same time, people in the natural language area, they realize, no, traditional convolution neural network for perceptual AI is not suitable for language processing. For example, if you look at this sentence, the animal didn't cross the street because it was too tired. What is that it? Obviously, it is not an animal. But the other sentence, the animal didn't cross the street because it was too wide. Then how about that it? So now you understand, the whole sentence, just the last word, gives you so much different meaning of that it. So the traditional convolution neural network cannot apply for this because convolution neural network always look at the local data, local window of the data, and try to determine a lot of information. So that the other architecture was invented, and it was called transformer. So transformer basically was invented to try to understand the whole context from beginning to the end of all the information you provide. We call it tokens. And the transformer architecture is like this, which I'm not going to follow you to talk about this. It will take me about 2 hours to finish this. Okay, but if you just understand transformer can be like the movie Transformer. Okay, so give you one idea. For example, if you want to do language translation from French to English, we just need to put the French into the encoder of transformer. Then something called cross attention, which allow you to understand what has been input from the encoder side. And then they quickly convert it into the English output one by one from the decoder side. So that is the transformers, encoder and decoder, which one side is performing useful embedding feature, the other side is trying to interpret what are the information are being presented. So how useful is transformer? Everybody heard about GPT. GPT stands for generative, okay. GPT stands for Generative Pre-trained Transformer. So GPT is the one which is specifically used for large language model. You just need to input a sentence. Now I don't even need to use the encoder side. I just put the data which has been encoding feature, embedded feature encoded into the decoder side of the transformer. Transformer will perform the prediction of the next word. So during the training, they only try to predict one word. What should be the next word? What kind of training? Internet, all different kind of internet sentence. And I want to learn, normally by giving so much input token, what should be the next word? So transformer is really no magic. It's just nothing but predicting next word. Okay? So, and that becomes GPT. And the GPT concept was very successful for language type of prediction. The people started to realize, wait, convolution neural network for image type of analysis and transformer for language type of processing. What if I want to relate text, English text or language text with image? And that is hard because right now there's no easy way. If I say something, what is the corresponding image? Or if I show you some image, what is the corresponding text? And that relationship, people start to think very carefully. And first, they try to see the possibility of using transformer also for image classification by introducing a very important transformer-based, it's called VIP. Vision transformer, and this vision transformer using one very special type of token called classification token, which allow that token to talk with all the pages of the images and understand what is the best embedding feature to describe the whole image, and using that one to perform the classification. And that leads to the very important invention in 2021 called CLIP. Okay, so CLIP is also the OpenAI's product, which is trying to align the image and the text together. When I say align, means it's not a possibility, it's any possibility. If I give you a sentence and I assign some kind of numerical value to that sentence, I also give you an image and also assign a numerical value to that image. I try to make them as close as possible. How to do that? They collect in total 400 million image and text description of that image from internet, and they push into allowing the whole sentence become one numerical representation. The whole image become one numerical representation. Push them as close as possible, and that is the first attempt try to align language and vision together. That's called CLIP. And once CLIP was able to do that, now our large language model becomes much easier, which can also take an image. And many of you know these days, a lot of GPT-4 or O1, they can also easily take an image. But the model is still called a large language model. And the reason is because our large language model can understand text, because image has been converted into language type of description. So if you ask where is the tower building in the image, and here's the answer. This large language model was not trained for any kind of image understanding, but because of that transformer's capability to convert the image into transformer embedding, and transformer embedding has been aligned with text. So the input to large language model is something called text-like type of visual information. Okay. So using that, people, including my students, quickly realize if we can understand image, what are the useful applications to understand image? Medical image. Medical image is one of the important applications every day in our daily life. So can you ask the transformer type of large language model to give you a medical report whenever you take the X-ray, whenever you take the MRI? And those are traditionally done by these radiologists or cardiologists. They have to look at your image. and try to give you a report. Those are very well paid. I was told more than $400,000 of salary. But now we can use large language model to do this job easily. Here is output from my student trained large language model. Okay, here is a human annotation. So this technique has been also working with Microsoft, and Microsoft announced it 2 months ago called medical image insight, which we work together with my student and Microsoft research, which they can read and writing report for more than 14 different kinds of medical images systematically. Finally, once you can use image and text to be interchangeable, in the past we tried to give me image and use text to describe it because caption, image caption, video caption. How about the other way, from text to image back? Okay, since they are aligned in terms of their embedding visual, is there any way I can make an image, create an image, generate an image based on the text only, and that's called image generation or video generation. And that was a new technique called diffusion. So diffusion idea is give me one image, and I keep on adding noise. Eventually, the whole image becomes noise. Once I take that noise, I predict what kind of noise was used to make the image become noise. I gradually subtract back that noise. I can get it back. If I use this, that's a very interesting concept. What if I insert my text here and say, okay, I want you to create an image, but I want you to create an image following my prompt. Then predicting that the noise can also be conditioned on the text you provide. And this is the idea. Basically, you have the original image, you plus this noise, then you become a blurred image. Now, can you use an artificial neural network to predict what was the noise added so that my image becomes so blurred, and I want to predict that noise. Once I have that noise, now if you give me any kind of noise, I can try to predict the corresponding image. And that leads us to this famous text-to-image generation. For example, the OpenAI's DALL-E and the Stable Diffusion. These are the text provided, these are generated image. These are the text provided, these are generated image. Okay. Different noise will give you a different image generation. And most impressive, everybody knows now we not only can use image to become text, or text to become image, we can also use text to become video. And this was announced last year in April by OpenAI's called Sora. So these are the text provided, and these are the video being generated. So what's useful? Okay, what's useful about it? I've been approached, even though right now I really don't have that kind of energy to help. But I've been approached by filmmakers. They want us to do what? Give me the script. They have more than 1,000 script and corresponding movie. They want to give me a new script and using this to create the movie. So, for example, if I want this to be my actress, and I don't like her dress, I like her to dress this way. Yes, you can do that. Then I want the actress to do this kind of motion, which is a simple hand waving dance. So now, this actress will become wearing this and performing that action. This action is not it's purely generated by my text to create that motion. And I can even make it a 3-dimensional body. So that's basically the perceptive AI and generative AI have been done in the past about 10 years. What's next? I don't know how many of you heard about all this new terminology called agentic AI. But before we talk about agentic AI, first, you guys need to understand a very important concept. Once the large language model has been trained by so much data from the internet, from some kind of spatial data, they are trained. But if I have some proprietary or some kind of newly updated information. For example, I want to ask, can you tell me how about my health report yesterday based on the symptom? So where's my health report? The health report won't be for the training data inside the large language model. So we will put those special proprietary information or some kind of newly updated information into a special folder. Another technique of appending special information on top of large language model is called a RAG, Retrieval Augmented Generation, which each time you send a prompt, they also go to this data source, which you don't want people to know, but you put it into a special folder. Then that prompt will go to this folder to retrieve some kind of useful related information and combine your prompt and that retrieve the information together to the large language model, which will give you a much more updated response. And that concept has been around for 2 or 3 years. But with that concept in mind, people quickly realize if you cannot have your proprietary type of database, can I also use any kind of information I like? So now we allow you to have your large language model to automatically go to search whatever information you like using something called tool functional code. So you can have a search tool, you can have calculator tool, you can have even a code interpret tool, database tool. You can have all different kind of functional coding mechanism inside the large language model. So whenever you send a prompt, they don't immediately give you the answer by predicting the next word. They first decide what kind of tool I should use in order to answer your question. And that concept is called agentic AI. Okay. So agentic AI is more or less the last year's kind of product. After this DeepSeek, after this GPT-01, people realize we need to do something a little bit smarter. Just don't use brute force. Always try to predict only the next word. So agentic AI, for example, if I ask you, look at the sky, do you think it will rain tomorrow? How does a large language model know? Because I asked the large language model to look at the sky. The large language model said, no, I don't have capability to look at the sky. The large language model will use the camera, will go to internet to search the weather report, to do a lot of things. Finally, the large language model will do the reasoning and they say, okay, from this current weather condition, I believe tomorrow will be hot. So that's called agentic AI, and that's the new trend. And these days, if you use a large language model, you will find out take a little bit longer time. That's because they are thinking, they are doing the reasoning. Okay. Shih-Chieh already mentioned I'm in charge of the closed-specific AI. So we identify 5 important future directions which we believe people can spend more energy trying to have breakthrough, which are robotic, healthcare, aging and longevity, or climate and sustainability, which relate to our global situation, or improving the AI efficiency because we realize AI requires too much resource. We need something smaller resources, smaller hard computing resources, smaller memory resources, which can still do the same job. So that's an efficiency issue. And also trustworthy AI, which is including the transparency and also the privacy issue. Finally, challenge. I also need to talk about challenge. Challenge is tough because I'm retiring. I don't really need to worry about challenge. Okay, challenge is for you guys. Okay. First, we know computer and scaling law. We need a lot of big model which require a lot of parameters, billions of parameters. We need a lot of data set, which require a lot of data set, trillions of tokens of data set. We also need a lot of GPU. So we are stuck because not so many people can have that. So how do we resolve that? No matter you come up with a more efficient model or whatever mechanism, you can use small amount of more data and you can use generative AI to generate related data. Whatever mechanism you can use, simulated data, so that you can still do a good job. That's called computer and scaling law. We also need to perform alignment with human. What do I mean by that? This is a very important concept. AI is being trained to create something which they learn from internet, but not necessarily internet's value of their output is not aligned with our human value. For example, when you are driving autonomous car, in front of you is one human and one dog, and if you have to kill one, which one you will kill? Okay, I don't know. Okay, depends on who you ask. Okay, so human value and the safety requirements are so difficult because those are not well embedded into the training. But if we don't do that, AI will make a decision which is sometimes against the human value. Finally, bias, discrimination, and ethics. Okay, ethics is a even more difficult issue. Okay, but different countries have different cultural discrimination and ethics. The same model used in Taiwan, used in America, used in Middle East may be different. How do you align the new model to the different ethics? That's also a tough issue. Okay, that's so much about my talk. Thank you very much.
Appreciate it. Next one, we will invite Mr. Kevin Chen. Kevin Chen is the CEO and founder of Autumn Rock, specializing in cloud, AIoT, and edge computing solutions. And with an extensive experience in leading the technology teams and developing advanced AI platforms.
Oh, wait, so I'm going to use this one. Well, it's great to see everybody here. How's everybody doing? It's good? This is like the unseen weather you're going to get in Seattle, so yeah. That's why we pick interview time in, like May and June, right? We never invite people here in February. Because they're not going to stay. But if you get this, turn in the lake around, they will take whatever offer you give them. And probably like $10,000 less too. Thanks for Dr. Huang. That actually reminds me of the reason why I don't want to be a doctor, is because I don't have that capability. So I only have one slide. And thanks to all this 30 slides introduction, I don't have to go through everything. But when we were looking into the journey of AI, a lot of people started to think, oh, AI has just been written 2-3 years, but it's not, right? It's been here for a very long time. Image is the very first thing, right? So audio is actually coming before that. So now we have a lot of applications like Alexa, right? Some of you have Amazon Alexa at home. And then you have each individual AI tool that popping up left and right. So in the past couple of years, image is the first one that come into AI. So I'm kind of just repeating what you had just heard earlier. But then later on, it becomes the language part of it. And which is really cool is that caught a lot of attention, right? Even though image has a lot of application, that we use camera to look at a lot of different objects. We try to analyze all the photos that you take on your phone or you upload on Facebook. But the applications are limited. So you know what actually caught people's attention on ChatGPT? It's all the kids are using it, right? So you even have a South Park episode about it. I'm not sure it is there, right? So that's how really that, you know what, if my 5th grader knows how to use ChatGPT, I better know how to use that because everything they wrote is better than what I wrote, right? So you just come think of it, then all this independent AI tools comes in. So the trend of what's coming next is really, if you talk about each individual AI, LLM, is really 2023, right? Agentic AI. So if you use AI workflow, if you use AI workflow, right? That's more like a 2023 and 2024. And now all the money is popping into really how each individual vertical that excels its AI capability. For example, you want to make a video, you have Sora, right? You want to write an essay, you have certain tools. You want to write code, there are like 3 or 4. Cloud just released something. And like Dr. just said, those are pre-trained models, right? Now they try to have a certain, each pre-trained model, each company has their own specialty. They are really good at certain things, and some of you probably use Gemini 2.5 that just released. So yeah, so it's like drinking water through a fire hose on actual AI study. So what comes next, really, is every single vertical that people are trying to focus in, that the business side is trying to focus on, is to go deep into the application side. So OpenAI is not only just training and training language model, but they try to go into a very specialized area, right? For example, like deep research. Right? So by using that, you will go into searching all the public papers. You use 4O model for certain things. You use the reasoning model for certain things. So those are the tools on the vertical side that we use. But what comes next? Right? It's very similar. This reminds me of a very old time when we are working on computers. Right? You remember that floppy disk you have, right? It was a 5 1/4. It stores 1.2 meg, right? And then you work on your computer, very happy, and you store this 1, 2, 3. A lot of people here from Microsoft will be using Excel. Not WordPerfect, but Word, right? And then you mail those to your colleague, right? And then they put it on a computer, plug into printers. What changed that is the networking. So network really changes everything. Through that coax cable, you create great company like Novell, right? Or Microsoft. Novell no longer there, but I used to remember I went to Salt Lake City. But you know, all this make people understand, hey, the work that I have can simultaneously connect to the other thing, which we see very closely in AI today. Each AI tool or each model they fine-tune, each data set they have is going to talk to each other. So if you look at 2024 and 2025, where the money is, where really all the technology they're going through the research is how to make those AI agents to talk to each other. They try to create this standard. Internet has been around for a long time, but what really changed the world is TCP/IP. Once we have a common protocol that they can talk to each other, then that will be the moment, right? Because when you're creating agentic AI, when you create your own AI agent to help you do certain things. For example, we walk into the office when you're taking a cup of coffee, your AI already read all the news today, right? And goes through all the comments that you have inputted on 3 different social media, right? And then also help you reply to it based on the current scenario, based on the background you have, just by prompting on every single different platform, right? And how those platforms talk to each other. If there is a generated way, a common way for them to talk to each other, that will be really what the next revolution that we can see is a TCP/IP moment for AI that's going to come along. I'm glad actually seeing a lot of the big companies. I think Microsoft is also one of them. Google, they are already taking this path. Okay, so what is really something that we don't see in today's AI? So all this information we have today in AI based on the training is reside digitally in the cloud, right? So everything is digitalized in the cloud. What is missing is the AI has to talk to the actual real world, right? So there are 2 missing parts. Well, not really missing part, but there are 2 really critical parts. One is, where is the data coming from? We train the image and tell that the image and say this is a dog, right? We train AlphaGo on how to play chess. We have to input all this method into how to play the game, everything into the digital world first. So we have to collect data. Data has to come from somewhere, right? We have a sound wave of a working engine. That actually has to have an actual sound wave that fit back into that and mark that, say, this is an okay engine that runs like this. This is what 3,000 RPMs gonna sound like. This is 5,000 RPM scan of sunlight, right? Sensing for chest image. Right? We have to use the data first, and then we have to mark the data, right? The second thing is that, okay, so now we have this wonderful thing that able to read everything. How about having AI to control? So those are really two things that we're gonna see once the actual digital part has been passed. So in the past couple of years, what's the most advanced AI that we're looking at, right? So it's mostly engineers. So they help us code stuff. Right? Why? Because all those data coming from GitHub. And so we have a lot of data that's already programmed. So we are trying to program ourselves up. Right? Because why? Because we have a lot of programming data already. Right? So that's what's coming. But we need to have something that go in out of the digital world to control into the physical environment. So what does that brought to? So this is what our vision of where we play that particular works. We provide the platform of an edge computing system that actually reside at the user side. So similar to Alexa at your house, right? It's close to the tool, to the device that you control. It's close to the place that you can collect the data. Of course, not consumer level, at the enterprise level. And then back in the cloud, we have a system that able to collect all the data. So where's the MCP? Oh, by the way, MCP is the current dominating communication level between different AIs. Because you are actually able to get all those information running your tiny little AI model at the edge, right? Looking at the sound wave first, determining what it is, collect that, and send it back, right? And also, you are actually able to plug that other people's developed AI into that edge side and make a determination. Cloud is a wonderful place to store a lot of data, especially historical data. So we have to use the cloud because once we go back, look at those refined data, we can run a regression training like the RED. They're using either it's a supervised or it's a reinforced one. Okay, so that's what we are coming from and try to see if we can plug that into the real world. And MCP connection is our major focus, really, at the edge side and the cloud side. So she asked me also about what Taiwan can do. By the way, I haven't really, before I made this slide, I haven't talked to the okay? But he already covered it. It literally just read my mind. So this is one thing from the industry we want to see in the government side. They say the 1 month in startup is like 3 months in a normal company, right? And in AI, 1 month in startup is like a year, right? So you just listen to the presentation of the whole AI history within 20 minutes, right? That actually is a lot of information. So for government, what we're actually seeing is that a lot of government want to say, yes, we want to go with AI, everything should use AI, but unfortunately, government still have something called fax number, that you want to apply something, you have a fax machine, and there's a number you can fax, right? I understand there's one government just finally retired a floppy disk last year that holds 1.44 megabyte, which, I don't know, it doesn't fit like a PDF, right? It's not even put on a PDF. So how can you actually use that and still have that in the government? So when the government says that, yes, we want to go with AI, everybody should go with AI, they need to get rid of that floppy disk by enabling more projects for us to do, and also providing more opportunity for us to go in and revamp the government project that, be able to not just talk about AI, but be able to work on something that changes the government, which I believe is going to be the next revolution of different countries. I'm thinking, Sen often say that one person can run $1 billion country, right? Which is really not lying. I think it is coming. Because when you look at that today, I can actually walk into the office, right? I will be able to perform 10 times more job I don't need an accountant. I don't need a lawyer, right? I can have all this thing done. I don't need to have the marketing person. I have 10 documents on there I need to sign, but AI already summarized everything for me, right? So all this can be done. So for a small country with 25 million people, if we are really able to utilize AI, have people understand AI, and you can think of the productivity and the GPT that the GDP that can create. So SoftBank was trying to say, yes, we're going to create this robot army, right? But really, what you want to create is one person that able to perform 10 times or 100 more times the job, the performance, to really make that. And academically, in the same way, right, we already have a lot of programs, which is wonderful, to be able to help us to hire people who actually in this field are able to replace. So yeah, that's pretty much all my slides today. And if you have a question, I'd like to take that later.
Right? They just recently launched the Autumn Cloud in Taiwan like 2 days ago. So it's a significant milestone for the Autumn Stride and also their global innovation efforts. Congratulations. Okay, so next speaker, we will have Mr. Zhong. Mr. YC Zhong, he is the CEO of Lumen, and he will discuss with us his journey and the intersection of AI and entrepreneurship. YC Chong is not only the founder, CEO of Lumen, he's also a Seattle-based startup recognized for its innovative smart key box solution for property management. And under his leadership, Lumen earned the prestigious CES 2019 Innovation Award in the Smart Home category, highlighting YC's commitment to advancing secure and automated property management technology. Welcome, YC.
Hello? All right. Let's switch gear a bit. Let's talk about properties. So millions of people invest in real estate for financial freedom, yet they lose that freedom because they are so tied up with managing those properties. So my name is YC. Thank you for the introduction. I'm gonna go through my journey here as well as my company. So I'm the founder and CEO of this company called Lumen. Our mission is really to build a real estate virtual concierge platform by harnessing the power of AI and access control, with the goal to help our target customers, which is real estate agents and property managers, to enhance their efficiency and reduce the overall operational cost. We self-funded this company, Lumen, at 2016. In 2023, we received our angel investment fund from National Development Fund from Taiwan. We are a Qualcomm Smart City member. We are also a member of Google AI Startup Program with 250,000 GCP credit granted. Here are some examples of our current partners and enterprise customers. The list goes on, so I cannot show all of them, but UW Medicine is our registered customer. In addition to this list, we are currently working with a few real estate associations and MLS to serve their real estate agents in some states. This is our headquarters. We are based in Bellevue, Washington, here in this place. And we do have other team members in other countries. We have a big R&D team in Taiwan, as well as India. And our support team is based in the Philippines. So let's talk about the problem that we are focusing. So as I mentioned, real estate agents and property managers are our target customers. When we talk with our target customers, try to figure out their problem, and the result was consistent. People don't have 24/7s. They don't work at night. They need to take a break. Sometimes when they need to handle their clients, they are missing out the opportunity to engage more prospects. And when they have a business, operational cost is really high. They need to be present on site with their client to show the house. And it's not just about managing the properties. It's all about managing people. So with that, as a result, they often had very hard time to scale their business. And the market is huge. So we believe, there's a problem, there is opportunity. U.S. real estate market is over $100 trillion in terms of the size. Our goal is to penetrate 20% of the access control market, which represent about $1.3 billion in serviceable obtainable market. The map on the right really shows our current product penetration today. Surprisingly, Texas is taking the first place now, followed by California, Florida, and Washington. So we need to catch up. To solve these problems, we have built a property management platform to help agents streamline their tasks and manage access control remotely. Most importantly, we want to help them gain valuable business insights. Our solutions has several different modules. I'm going to quickly go over them. The core management really not only help agents to manage properties, but also manage those devices when they need to show the homes. In addition, we have people management with different level of permissions. We also have ledgers to integrate the payment systems. Last but not least, we want to shine real estate agents' brand, so we have their brands on top of as an interface when they talk to their clients. Showing schedule automation really is our signature. We automate the scheduling process. Our self-schedule is just like Calendly plus access control. Listing agent can share their property URL, the web handle, with their prospects or buyer agents to let them self-schedule the visit. Once the visit is successfully scheduled, our system will issue an itinerary to the visitors. The itinerary will be just like the boarding pass that you would use at the airport. So we also integrate virtual agent in on top of the itinerary. So when the prospect or the visitors tour the home, they will be able to interact with this virtual agent, especially when the listing agent is not available at that time. All the communication dialogues between the virtual agent and the prospects will be captured and shared with the listing agent. So it's super transparent to the listing agent. At the end of the day, really, it's the human makes the final decision, not the AI. So we do have a big presence in terms of the hardware access control. On the left, we have our proprietary smart camera key box. And so on the very left-hand side, you can see this itinerary where we show the access control. On top, there is a virtual agent. We also partner with other smart door lock manufacturers to integrate with our software platform. Let's show the...
Unlocking time for a prosperous real estate business is what listing agents strive for. With Lumen's property management platform, you can keep tabs on your prospects and list your properties from anywhere. After ID verification, prospects can self-schedule visits on your booking page and explore suitable listings at their convenience, both online and offline. Worried your prospects might miss the selling points? Virtual Agent can help answer prospects' questions and keep you informed.
I love this kitchen. Hey Shelly, was this kitchen updated recently?
I am glad you asked. Yes, the kitchen was upgraded with the stainless appliances last month. Are there any specific amenities or features you would like to learn more about?
What do you think?
I love this.
Hey Shelly, what do we do to make an offer?
Sounds great. I have just notified the listing agent and he will contact you directly.
Lumen, your real estate virtual concierge. Unlock your time for a thriving real estate business.
So that's kind of give you a sense in terms of our end-to-end experience and the experience that we deliver to our target customers. So what we are really building is a flywheel to connect the prospect and agents through the data integration and automation. So we are trying to be this bridge. On the left, there's a supply, the people who want to sell their house or rent their house. On the right, we have demands, people who want to buy a house or rent a house. Talking about money, I got to talk about it. So we charge one-time fee for the access control device, and then after that, we charge subscriptions for the services and data. For those third-party hardware partners, we are happily receive their commission to integrate with our software platform. We do have a lot of options today on the market in terms of property management solutions. One of the biggest competitors that we are having is Supra, which is currently #1 Bluetooth-based device for real estate agents in the United States. We have a world-class team. Thank you. Some of you has been helping us. Our team came from Microsoft, MediaTek, and Compass with deep knowledge in tech, design, and real estate. So if I still have some minutes, I can quickly demonstrate our real estate virtual agent experience. I cannot demonstrate everything, but just this one. So you're gonna hear some sound from my phone. This is the itinerary that we send to the prospect. So if they have any questions?
Hi, I'm Shelley, your virtual agent. Feel free to ask me anything about this property. This conversation will be recorded and shared with the listing agent.
Hey Sherry, I like this house. How much is this house?
Welcome to your dream home. Priced at $899,000. This stunning property won't last long. Talking about the price, have you already been pre-approved for a mortgage?
Yeah, I do have the pre-approved letter. Thank you. So you can kind of get an idea, this is not just about answering questions to the prospects, but also prompt more information by asking those prospective questions. And we know the real estate agent has a lot of questions when they engage with their customers. And last but not least, one sec, very quick. There. And so this is our current software platform for both listing agent and buyer agent. And so we just had a conversation and with the virtual agent. And as a that was this property. And so, I as a listing agent, I know there is I know there's a prospect visiting the house, and I can always go back to the history. I can view all the dialogues that the virtual agent had with this prospect. And so I'm not going to miss any beats. And if there is a potential lead or interest to move forward, our system will notify the listening agents. And so I think for the next natural step will be, we will probably summarize what we learned from the prospects, and further help our listening agents to understand their customer better. I think that's all of my presentation. Thank you.
Okay, next one we will have our last but not least speaker, Dr. Shih-Chieh. He is the CTO of Immunome, and he will talk about the latest advancement in AI for biotech.
Yeah, I want to thank the organizer for inviting me to this event, and I realize that I'm with very smart people on the panel, so it's my privilege to be here. Good evening, everyone. Yes, that is my slide. Good evening, everyone. My name is Shih-Chieh. I'm the first generation Taiwanese American. I grew up in Chicago, spending a few years living in Boston for work, and I've been living in Seattle for the last 22 years. So I realize I'm the odd man out. I'm not going to talk about AI, nor talking about digital. So I thought I'd give a brief introduction about biotech, as well as drug development, because that's what I know. There we go. So biotechnology, as the name implies, that means we're using the molecular or biological system to solve industrial problem. And in the case I'm going to talk about, it's going to be talking about drug development. So I'm going to use four simple examples, or four examples of biotech in drug development or in the cancer therapy to sort of give that introduction. And by no means that there are way more than these four examples out there. So the first one I want to talk about is using antibody or antibody variants to block the pathway that cause disease. All of us, we have lots of antibody in our system. In fact, this is our way to fight infections. Every time when there's an infection, there's our B cell. So B cell is part of our white blood cells, and they recognize that foreign particle or antigen, and it will subdivide into plasma cells, and that plasma cell will generate lots of antibodies specifically against the antigen of that foreign particle. And then our human body would make millions of these antibodies and release into the bloodstream, and then the antibody will bind to the antigen and neutralize it. So one of the applications for biotechnology is use that, right? Using monoclonal antibody, the specificity of the antibody against a target. And in many cases, those targets are the pathway that involve in generating disease. So there are two drugs that I'm going to talk about. The first one is Ambro. So as you know, inflammatory disease, those are hyperactive immune system. So the reason why we have rheumatoid arthritis or psoriasis is our immune system thinks that our body is foreign and is attacked. And so how do we block that pathway such that it can throttle down our disease? So an example of that is Ambro. They used TNF-alpha. So TNF-alpha, that's the receptor that is involved in the pathway of inflammation. And so this company invented or developed Ambro to bind that specific target or receptor, and then deactivating the inflammation pathway. So that's an example of Ambro. There's another drug that is similar in the sense that it binds to CGRP. CGRP is implicated in migraine. So what this drug does is that it binds to that target, and then in our bloodstream, and then that throttles it. And then that specifically, that drug, UEPD, is specially formulated such that it has long circulating half-life. So you only need to dose this 4 times a year in 30 minutes infusion to manage your migraine. So that's an example using antibody. My second example, if if you take the antibody a little bit further, antibody binds specific to a target, right? Why not develop an antibody that binds to two targets? And why would we do that? So nowadays you hear a lot about immunotherapy, using our immune system to fight the disease, right? And so in this case, you could have an antibody engineered in such a way that one arm binds to a T cell, that's our immune cells, and the other arm binds to the target of the disease, so in this case, it's tumor cells. So by doing that, you bring the T cells close to your tumor cells, and then the T cell would kill the tumor cell. So that's the hypothesis of how they would work. So in this example, there's a drug called Ziihera that binds to the two domains of HER2. Now, HER2 is a genetic mutation that is commonly found in a lot of tumors, so breast cancers, in lung cancers, in colorectal cancers. And in this case, it binds to two separate domains of the HER2. And by doing that, it increases the specificity and also increases the activity. And so this drug is recently approved in November of 2024 for HER2 positive biliary tract cancer. The third example, if you take that antibody concept a little bit further, now you have an antibody that can bind to a target, and hopefully the target is on the tumor. How do we further enhance the killing of the potency of that antibody? Well, what you can do is conjugate it to a warhead or to a drug that specifically kill the tumor. So in fact that you develop your drug with the antibody bind to a antigen on the tumor side, but not on your normal healthy cells. And then that, by binding of your antibody to the receptor on the tumor, then you internalize that, along come with the drug that is attached to a drug, to your antibody. When it's got traffic to your lysozyme, the enzyme release the payload, and then the payload go and destroy the cells. Now, when the cell lyses, then you have the payload, it will migrate to the surrounding cancer cells, and then if it's permeable, then that gets inside another tumor cells and kills it. So this technology is called antibody drug conjugate, and it's recently quite a few therapy with antibody drug conjugate has been approved by the regulatory agencies. The three drugs I'm talking about that I have listed here, Adcetris, Padcev, and Tivdak, they are indicated for various types of tumor, both liquid tumor and solid tumor. So, such as Padcev is indicated for Hodgkin disease, and Padcev for bladder cancer, and Tivdak for cervical cancer. And then my last example is cell therapy. So I talk about the concept of antibody and also the T cell using our own immune system to kill tumors, right? In many tumors, the tumor is smart. It figures out a way how to evade your own immune system. Or there are other type of tumor that our T cells, our immune system doesn't recognize the tumor. So what do we do in that case? Well, what you can do is you can engineer your T cells to attack the tumor. So this cell therapy, the way it works is that you have a cancer patient you identify that for this particular type of therapy, you go to a hospital, they would draw blood, and the blood would then, you would go through a apheresis to remove your T cells and separate your T cell with other cells. You isolate the T cells, and then you genetically engineer the T cell by putting in what they call the chimeric antigen receptor T cells. So you try to express that particular antigen that is on the tumor cell that your original T cell doesn't recognize. Now, the resultant T cells now will have the antigen, and when you put it back to the patient, then that your T cell then recognize that tumor, and then it will go attack it, right? So this is another way to. This is another example of biotechnology development. The use of biotechnology for drug development. And the example I have here is Breyanzi, and that's indicated for various types of lymphoma and leukemia. So those are the 4 examples I'm going to share. Now, besides, they all derive from biotechnology. What else do you think all these drugs that I mentioned have in common? Well, they're all invented here locally. So all these drugs there are a lot of other drugs that I listed here that I didn't talk about, but they are all variations of these 4 examples that I have. Now, these are important drugs. Most of these are for cancer treatments, and most of these are for patients that are on the last line of hope. So they have failed other therapies, and then they come in 3rd line or 4th line. They've gone through chemotherapies, and they have really they're just waiting to die. And so these drugs help them extend their survival, and so they're important in saving patients' life. The other important thing is collectively they generate more than $12 billion of revenue for the company that sells these, and more importantly, that get back to the improve the economy, the local economy, as well as putting back the earning back into developing the next generation drug. So here in Seattle, we have great research institute such as UW and Fred Hutch that trains and attract talents, and so our local biotech economy is growing. In fact, in 2025, Life Science Washington published a report that says that Washington State is top 10 in terms of biotech cluster sectors in the industry of United States. And then another interesting fact that in biotech technology, the ratio of women to men is high relative to other industries. So we have 45% of women with STEM degree that employed by the biotech industry relative to other prominent Washington State like aerospace and high tech. And also collectively, biotech in this region employ close to 50,000 people, and then generate $42 billion of making $42 billion of economic impact. So it is not a small industry, and it's thriving. However, biotech industry is tough business to be in. It takes a long time and it's expensive, and not everything works. In fact, the probability of a drug works is very low. So most of the biotech fail, and they fail because 1, they ran out of money, and 2, that their drug did not work, and they didn't have more funding to continue their development. And so statistically shows that 1 out of 10 drugs that enter the clinical trial will finish the clinical trial with the approval by the regulator. So it is a small percentage. Drug development is time-consuming and costly. So on average, I would say that drug development takes more than 10 years from beginning on the concept in research all the way to market approval. For oncology, it could be faster. That's because there's highly unmet medical needs. So our regulator, FDA, and the industry have a motivation to move fast to treat the patient. The average cost for developing a drug is more than $0.5 billion. And if you count the failed drug, then it's that amount doubled to $3 billion. Manufacturing process is complicated as well. It involves many different technology. So biotechnology use live cells or biologic system to make your drug. So here's an example of how we make antibody drug conjugate. So you grow the cells in bioreactor, and typically 500 to a multiple thousand liter bioreactor, and then you have to purify them, right? You use the cells. The cell doesn't just make your product. You make a whole bunch of other whole cell protein that you have to purify away. And then from there, you have to do conjugations, and you do formulate it and put it into the vial. Because the ABC is likely sensitive to temperatures and lights and whatnot, then you really have to formulate well, and typically we freeze-dry the protein. So many different technologies involved in manufacturing that ADC. From start to finish, typically it would take close to a year just to do that. The supply chain is complex too. So, there are very few people in the world that can manufacture an antibody-drug conjugate in one shot, meaning that antibody-drug conjugate as well as drug product. So, we're talking about what the supply chain spread out over the globe. And from the time you manufacture to warehousing, to testing and distribution to the patients, now these drugs, they are specialty pharmaceuticals. You can get them over the counter. And so oftentimes they are delivered to the patient just in time. So you need to have a robust supply chain distribution system to make sure that the patient gets their drug every time they need it and whenever they need it. So as an example, I work for a company called Immuno, and we're still a clinical stage company, and yet we already have 33 suppliers globally. So drug development is hard, right? The odds against a successful biotech drug company is low. Why do people continue to invest in this? Why do I do what I do? Well, so I do that because I want to make a difference in cancer patients' lives. I know that statistically, if I do a survey, that every one of you either are impacted by cancer or have someone that are impacted by cancer, right? It's a statistic, and everybody's life is impacted by cancer. So I feel very rewarding, and I found purpose in doing this type of work, that the stuff I work on today in 10 years might be helping to extend patients' life. Here's an example of the drug that I worked on. So this is PESF. It's for treating first-line metastatic bladder cancer. So the graph shows that this drug essentially doubled the overall survival rate, compared with the standard therapy before. So it's the data like this, make me wake up every day and want to go to work and do my job better. So with that, thank you very much for your attention. I'm happy to answer any questions.
Okay, we need to invite all the speakers come upstairs. We have small gifts for you. Then we'll take a picture together. We'll do one more photo.
大家手指站起来。好棒！Hello 整个 AI 的大会现在是基本上结束了，大家现在就是吃点东西，然后就各自交流一下。
我们等一下要拍成大合照哦。
不错不错。
这个美一些，这个也没有办法起我。
现在大家都在热烈的讨论。
你们就是
标币还有加州。
我们看看那个有没有大家熟悉的朋友。哎 ，say hello。哎，差不多，现在是互相交流，看他们，差不多。
我现在还在这里，我现在在新创，公司去新创，然后做 scale 的。没有了，没有什么厉害，我看着你的履历好羡慕，很厉害，很厉害，超厉害。
都不少年，2016的时候。
相信这次 AI 的研讨会对大家都有很多的收获和启发，大家期待着未来的发展。那我们现在就为大家报道到这里。AI 的研讨会已经结束，现在大家就是吃饭，然后就回家了。欢迎大家的收看，我们下次再见，感谢大家的支持。